Welcome to the course on Python for data analytics, machine learning, and generative AI. This session introduces data visualization not as an auxiliary skill but as a core analytical practice.
Here, we will learn how to create interactive and visually appealing charts. This session will cover importing Plotly, trend visualization using line charts, categorical comparison using bar charts, relationship analysis using scatterplot, distribution using histogram, proportion using pie chart, donut chart, spread and outlay using box plot, violin plot, and 3D scatter plot.
By the end of this session, you will have developed a structured understanding of data visualization as an analytical practice rather than a mechanical task.
In earlier modules, we worked with static plots using matplotlib and seaborn. Those plots are useful, but they do not allow interaction. Plotly changes that. With Plotly, users can hover, zoom, filter, and explore data dynamically.
So, let's open Jupyter Notebook and start writing some Python code together and bring the concept of visualization to life.
To begin, Plotly must be installed using standard Python package managers. Once installed, the library can be improved into your Python environment. This setup allows us to start building visualizations immediately. Let us begin by importing the required libraries. We import Plotly Express, written as PX. Plotly Express is the high-level interface. It is designed for speed, clarity, and ease of use. With Plotly Express, you describe what you want to visualize, not how to build it. You provide the data set. You specify which columns map to the axis. Plotly takes care of the rest. Import plotly.graph underscore objects as Go brings in the low-level object-oriented interface of the Plotly library. Here, the visualization is constructed explicitly. You define the figure, each trace, and the layout. Nothing is assumed. Nothing is automated unless you specify it. df is equal to px.data.tipsof function call imports the tips dataset, which contains real-world restaurant transaction data and is commonly used for demonstrating data visualization techniques. The command df.headof is then used to display the first 5 records of the dataset, allowing a quick inspection of its structure and contents. The command dir of px.data is used to explore the content of the px.data module within Plotly Express and identify the datasets that are readily available for analysis and visualization. Python returns a list of attributes and datasets names associated with the module. We now check the dataset wind mentioned the dataset. This dataset contains summarized meteorological information related to wind behavior and is particularly useful for demonstrating categorical and frequency-based visualization. Line charts are useful for visualizing trends over time. In Plotly, line charts are created by mapping data to axes. Interactivity allows user to explore values by hovering over points. px.lineof demonstrates how to create line charts in Plotly to visualize trends in the total bill values from the tips dataset. In the first case, a baseline chart is generated. The result shows a simple trend visualization that shows how total bill amounts vary across individual observations. Plotly automatically handles axis labels, scaling, and interactive features such as hovering and zooming. The chart title provides through the title parameter clearly communicates the purpose of the visualization. Now, the line chart is extended by introducing the color is equal to day parameter, which groups the data by the day of the week. This causes Plotly to draw separate lines for each day allowing direct visual comparisons of total bills trends across different days. Bar charts are commonly used to compare categories. Plotly enables easy customization of colors, labels, and orientation. These charts help highlight differences clearly and effectively. Bar charts in Plotly are used for categorical comparison, focusing on how total bill values vary across different groups in the TIPS dataset. px.baroff is used with day on the x-axis and total bills on the y-axis, producing a bar chart that summarizes total bill amounts for each day of the week. Plotly automatically aggregates the numerical values for each category, allowing an immediate comparison of overall billing patterns across day. Now, by specifying color is equal to 6, the bars are split by gender, enabling a comparison of billing behavior between male and female customers within each day. The parameter facet_row is equal to time further divides the visualization into separate rows for lunch and dinner, effectively creating multiple aligned subplots. This bar chart allows viewers to examine how total bill pattern differs simultaneously by gender, day, and time of visit, demonstrating how Plotly supports complex multi-category comparisons with concise and readable code. Scatter plots show relationships between two numerical variables. Plotly enhances scatter plots with interactive markers and tooltips. They are especially useful for correlation and pattern analysis. Scatter plots in Plotly are used for relationship analysis, particularly to examine how the tip amount varies with the total bill in the tips dataset. The interactive nature of the plot allows users to hover over points to view exact values and to zoom in on dense regions, which is helpful for identifying patterns or outliers. By giving color is equal to time, parameter differentiates observations based on whether the meal occurred during lunch or dinner, while size is equal to size scales the marker size according to the number of people at the table. The symbol is equal to 6 parameter introduces different marker shapes to represent customer gender, and facet color is equal to day divides the plot into separate panels for each day of the week. Together, this encoding transforms the scatter plot into a multidimensional analytical view, allowing simultaneous comparison of tipping behavior across days, meal time, group size, and gender with minimal additional code. Histograms in Plotly are used to examine the distribution of numerical data, focusing on total_bill variable from the TIPS dataset. This visualization helps reveal the overall shape of the distribution, including common bill ranges, spread, and any skewness, while Plotly interactivity enables precise inspection of frequencies through hover information. Now, by adding color is equal to 6, the distribution of the total bills is split by gender, making it possible to compare patterns between male and female customers. The n bins is equal to 40 parameter increases the number of bins, providing a finer grained view of the data, while hist norm is equal to percent normalizes the frequency so that the y-axis represents percentages rather than raw counts. The bar mode is equal to overlay option places the gender-based histograms on top of each other, emphasizing similarities and differences in their distributions. Together, these enhancements demonstrate how Plotly histogram can move from simple distribution analysis to advanced group-based comparisons with minimal code changes. Now let's see pie charts in Plotly, which are used to visualize propositions, specifically showing how the total bill is distributed across different days of the week in the TIPS dataset. Each slice is automatically labeled and color-coded, and the interactive hover feature allows viewers to see exact values and percentages, making the proportional comparison clearer without cluttering the visual. The donut chart example extends the idea of a pie chart by introducing a hollow center, which is achieved through the whole is equal to 0.5 parameter in the px.pyof function. The donut chart retains all the interactive features of the pie chart, such as hover-based percentage and value displays. But the central empty space improves visual balance and is often preferred in dashboards and executive summaries where clarity and aesthetic matters. A box plot is a tool for understanding data spread and outliers. When created using px.boxof, a box plot summarizes the distribution of a numerical variable through its median, quartiles, and extreme values. The box represents the interquartile range. The line inside the box marks the median, and whiskers extend to show the range of typical values, while points beyond the whiskers highlight potential outliers. This type of visualization is particularly useful for comparing variability across categories and for identifying unusual observations that may require further investigation. In this example, we create a violin plot using Plotly Express to visualize the distribution of tips. The data frame is passed as df with days mapped on the x-axis and tips value on the y-axis. Each violin represents the density of tips for a specific day of the week. By setting box is equal to true, we embed a box plot inside the violin for summary statistics. This allows us to see both the spread and the median of the data simultaneously. The title clearly describes the comparison being made across days. Here we generate a three-dimensional scatter plot using px.scatter_3d. The x, y, and z axis represent total bill amount, group size, and tip respectively. Color is assigned based on the day to distinguish different categories visually. The size of each marker is scaled using the total bill value for added emphasis. This visualization helps analyze relationships across multiple numerical dimensions. The interactive 3D rotation allows deeper exploration of the data structure. Interactivity is a key strength of Plotly visualization. Users can zoom, pan, and hover to explore data in detail. Here, the table summarizes the different Plotly functions, such as px.lineof for trends, px.baroff for categorical comparison, px.scatteroff for relationship, px.box or px.violin for distribution analysis for your reference. Thank you.